This video, we'll begin discussing what we call identities. In this case, these are the fundamental identities for trig. What an identity is that you can literally plug in anything you want into the equation that exists, the identity, and it will always have equality. So what that means, like here, that means that this will always be true, regardless of what t is. There's some restrictions here. I can't let cosine be 0, right? Because if cosine's 0, it's undefined. But outside of that, I can plug in whatever I want. This also makes sense to me for tangent because sine is typically defined as y, and cosine is defined as x, which gives me my tangent ratio that we discussed in the previous. The secant, remember, to go from cosine to secant, I would just flip it over. So this also makes sense, right? If I want secant, I just take cosine and flip it over. Same thing with cosecant, right? If I cosecant is just sine flipped over. So these could also go the other way, right? Cosine of t is 1 over secant. Sine of t is 1 over cosecant. We have those same definitions. Cotangent is 1 over tangent. But if tangent is sine over cosine and cotangent, I just flip it over, that means cotangent would be cosine over sine, right? And this makes sense because cosine's x, and that's y. So these will start popping up. Let's go ahead and work these that we have here for examples. I have tangent of 45 degrees. I like to use radians, so I'm going to flip it to pi over 4. Okay, pi over 4 is in the first quadrant, quadrant 1, and it's the mid triangle, right? Mid, which means this is rad 2 over 2, and this is rad 2 over 2. So if tangent is sine of pi over 4 over cosine of pi over 4, then sine of pi over 4 is rad 2 over 2. Cosine is rad 2 over 2, which is going to be 1. We could have seen that at the very beginning because we know tangent's y over x. And at the middle triangle, tangent's going to be 1 because the sides are the same. All right, let's do cosecant. All right, I got 7 pi over 6. First thing I'm going to do, let's write out the identity. 7 pi over 6. This is going to be 1 over sine 7 pi over 6. So we got to figure out what 7 pi over 6 in sine is. 7 pi over 6 is in quadrant 3, and it's the short triangle. So the short triangle, this is rad 3 over 2. This is 1/2. This is 1. So sine is the x, so I'm going to get 1 over radical 3 over 2. We got to be really careful, or I made a little mistake. These are both negative because it's in quadrant 3. So this ends up being negative 2 rad 3 over 2. I think over 2 or over 3. Let me go ahead and flip this real quick. Rad 3, if I flip rad 3 over 2, it becomes 2 over rad 3. If I rationalize, okay, that's a 3 on the bottom, not a 2. All right, there we go. So that's why we maybe want to go ahead and flip it and figure that out every time. It can be really easy to mix these up. So maybe flip that over and rationalize, and you'll get to that. Right, C. Okay, secant of 5 pi over 6. That's just 1 over cosine, because it goes with cosine, 5 pi over 6. And then I got to figure out where that is. Okay, 5 pi over 6 is in quadrant 2. And over 6 would make it its short triangle. So this is 1/2 positive. This is negative rad 3 over 2. And that's a 1. So it's 1 over cosine. So it's going to be 1 over negative rad 3 over 2. That's kind of helpful because we get the same value that we got on the previous one. All right, that's how we use those, right? Just flip them over, plug in what you know. That's why we only actually really need to focus on sine and cosine for the unit circle, because everything else we can get there. I'm going to shrink this so I have room. All right, A and B here, and that'll be the end of this video. Okay, simplify says secant over tangent. So what we're going to do here is, and we're going to be doing a lot of this later in the semester, but they're going to preview it here. Secant is 1 over cosine. So I just change that. Tangent is sine over cosine. So notice that this is a fraction within a fraction, which means it's just division. 1 over cosine t divided by sine of t over cosine of t. This is 1 over cosine of t. I change it to multiplication, and I flip my fraction. And notice what's going to happen here. The cosines are going to cancel, and I'm going to get 1 over sine, which is cosecant. This is a little proof you just did. We're going to do a lot of these later. They're going to get a little more complicated, but I'm going to start showing you the simpler ones as we go along. All right, so there's that one. They want us to, and that's all we have to do. We know now that this thing is equal to cosecant t. We made an identity. We can plug whatever we want in there as long as the tangent's not 0. The next one, tangent times cosine. I'm going to write their definitions. Tangent, oops, I wrote tangent again. Tangent is sine over cosine. And then I'm going to change this cosine to just cosine x over 1. And the cosines cancel, leaving me with a sine x. So that whole thing is equal to sine x. And you may be wondering, like, why do I care? Why would we do that? Well, as I struggle to draw an S, my handwriting is weird if you haven't noticed. I start a lot of figures from the bottom. But sine, why do we care about this? Well, when you guys get to calculus, doing calculus on this versus this is a big difference. The one on the left will require a lot more work, while this is just one more step, or just one step to do the calculus topic that we're headed towards in the next semester.